In this video, we are going to explain the NTP protocol, which is the network time protocol. This is the third-level protocol, which is the network client. He uses the port, which is UDP 123. This makes a sync for the time of a computer with the server. It means it makes a sync for the client time with the server time. Let's see. It means I have a router that I consider it a server, and every router, or every device, is considered the client of the router. We know that if the time of the device is different from the time of the servers, there is a problem in these devices. These devices can't take services from the servers. For example, if you have a server, which is the Kaspersky, and it scans the devices and it updates the antivirus that it has. If R1, he will have the server, and he will be able to scan these devices, or update them, or he can manage them. We have two scenarios that we can do. In R1, he will have the server, and he is the one that will give the time to R2 and R3. R3 and R3 will give the time to R4. R2, he'll give the time to the devices he has. That's it. How R1 is going to get the time from his internal clock? In this case, R1 is called NTP master, or NTP server mode. This is my server. R2, R3, these are the clients. We call them NTP server, NTP server client mode. R2, R3, they are client. We call them NTP server, NTP server client mode. R2, R3, they are client for R1, and server for the devices that they have reached. R1 is the NTP master, it means it's our server, and it will give the time for R3 and R2, which are NTP servers. R2 will give time to the devices they have, and R3 will also give them time to the devices they have. The second scenario is that R1, R2, and R3, all are NTP servers client R1 to mode. They are all client. R1 will take the time from the internet, and it will give this time to R3 and R2. The NTP master is the server on the internet that I take from it. The most famous server,
ntppool.org.
We can make this R1 take more than the server, so if an error happened in any server, it can take the time from the other server. There's a thing called NTP stratum. As we said, every device gives the time to the device that is connected to it. Every device is a hub. This means that this is the number of hops, or the number of devices that take this time. For example, the server gave the time to R1, and R1 gave it to R3. The default is 8 for the stratum, but the highest value is 15. We'll get on the router is 8, and the next is 9, and the next is 10, and so on, until it reaches the 15. Let's see the first case. In router 1. Write sh clock. We find that clock not synchronized. First I will set the time zone between Egypt and USA. I'll write the time clock time zone, and then I'll write here any word that means, for the organization. To know how the time difference between the United States is, I'll go to Google and write my country's name. I'm from Egypt, so I'll write Egypt time zone. I'll find the time for 2 hours. I'll write 2 o'clock. Then I'll set the time and I'll write 6 o'clock. I'll get the first hours, then the second hour, then the second hour, and then the date. I'll write show_clock to see the hour. Through the command, you're the master. After the master, I'll get the stratum. But I'll leave it on default, and I'll leave it 8 o'clock as it is. So it's not a problem. R3, let it take the time from R1. When we're going to connect R3 with R1, we give R3 the IP of R1 so he knows how to take time. But if there's a problem in the interface that is connected to R3, R3 will not be able to connect to R1. That's why we're going to make an interface loopback on R1. In this case, R3 wants to connect to R1, he will find any port to get it. He will not find any route to get it, he will not find the port that is connected to it. This is what we call the availability, the interface loopback. The interface is an imaginary interface, not hardware. It's not a real port. IP address, 10, 10, 10, 1, 255, 255, 255, 0. I'll give it IP, not in the range of the devices I have. IP is completely different. I'll call it NTP source loopback, 0. And now I'll go to the router 3 and I'll say, clock time zone EG2. When I write show clock, you'll find the time is not right. I'll show it to him on LR1. I'll write NTP server 1010.1. Asynchronous takes time until it gets to be called. We'll wait a little bit and we'll write the show clock. We'll find it to be added. If you have written show_clock_detail, he told me that the source is 10.10.1 and the reference is 10.10.1 is the local. I've written show imp status, you'll see that the straton is 9 plus 1, and the reference is 10n1. For the R4, he will take R3. We'll write the same instructions. Click time zone, EG2, NTP server, 192, 168, 13. This is the R3. I'll write show NTP status, I'll see the stratum is 10, and the clock, it's and the reference is 192, 168, 13, and that's it for the rest of the devices. Let me look at the second scenario. The difference between the two scenarios is that the R1 will take the time from the internal clock's internal clock or from the internet server. In the first scenario, it will take the time from the internal clock's internal clock. In the second scenario, it will take the time from the I don't have a router master. My server is not a router, but a server on the internet. Here, I don't have a router master. The server is not a router, but a server on the internet. The most famous site is ntpool.org. How do I know the IP of this site? I can go to the CMD and I'll write binged.pool.org. It will see the IP of it in this way. Or I can go to a website called www.slockup.io and I will enter the link to the website that I wanted, and it will immediately give me its IP. That's how I got the IP of the server.
Clock time zone
NTP server. And I'll write the IP of the server on the internet. When I type show NTP status, it will say that the clock is synchronized. The rest of the routers, R2 and R3, we're going to make them the same configuration that we did in the first scenario.